Hello, I'm going to explain this problem. A 132-foot antenna is on top of a tall building. So that's the antenna height right here. That is 132 feet. From a point on the ground, so we have a point over here, the angle of elevation to the top of the antenna is 28.5 degrees, while the angle of elevation to the bottom of the antenna from the same point is 21.5 degrees. How tall is the building? So first, we don't know how tall the building is, so let's make sure to label that as x feet. Right now, before I add the angles in there, what I wanted to do was to explain. Sorry, let me just here. Right, explain or remind you what the angle of elevation was. Angle of elevation means you're going from the horizontal, so in this case, the ground, and you're looking up. So you're measuring from the ground up to kind of an imaginary line that you're drawing to the top of your antenna. So that is what the angle of elevation is. So that's the angle of elevation to the top of the antenna. And if we're doing the angle of elevation to the bottom of the antenna, you're drawing again an imaginary line from the point of measurement to the bottom of the antenna over here, and you're measuring up, so to speak, from the ground up to that imaginary line. All right, I'm going to add the numbers and the degrees to my diagram in just a moment, but I wanted to explain again what the angle of elevation was and what generally the problem is talking about. So let's generalize this diagram into something that we can use to solve. Here you go. So you'll notice I have kind of my previous diagram with my pretty antenna and buildings up in the corner, but this is a diagram we're going to be using to solve our problem. So we have x is our unknown, that's the height of the building, plus 132 because that is the height of the antenna. And then you'll notice 28.5, of course, is the angle of elevation to the top of the antenna, all the way to the top. And then at 21.5 is the angle of elevation to the bottom of the antenna. The bottom of the antenna is also the top of the building. So if you didn't get that from the diagram over here, right? So the bottom of the antenna, top of the building, that's the same thing. Now, one thing I added, one more variable I added here that you'll notice is D, right? So I'm saying D is the distance between the building and the point of measurement. And that's going to come in really handy when we try to solve our problem. So again, so you'll notice the D over here. All right, so we've got our diagram. Now let's solve. I take my Oh, no, it worked. Okay. So here's our diagram. Now for this diagram, this is one thing I forgot to mention is this is a right triangle. This is a right triangle problem. And so we're going to be using our basic right triangle identities. Now you'll notice that what we have in this triangle is relative to the angle, we have our opposite side, and then we have our adjacent side. So what we're going to be using is the tangent function. The tangent of any angle for a right triangle is the opposite side over the adjacent side. Now, as we solve, you are going to need your calculator. So remember that your calculator is in degrees. If you're using decimals, you can also change that to degrees as well. So step one. From the dotted blue triangle, that's the smaller blue triangle over here, I'm going to say tangent of 21.5 degrees is x over d. That's my opposite side over the adjacent side. From the big green triangle, what I can see is that in my big green triangle, you'll notice this entire side over here, that's my opposite side. And of course, that's the sum of the building height and the antenna height. The total height is x plus 132. That's x plus 132 over d. Again, that's the distance from the bottom of the building to the point where we're measuring from. And that is tangent of 28.5 degrees. All right, so that was step one. Step two, I'm going to solve both equations for d. So that just means I'm going to rewrite the equation so it's in a d equals format. So this is d equals x over tangent of 21.5. This is d equals x plus 132 over tangent of 28.5. Now, because they both equal d, the really cool thing is that we can set both of these equations equal to each other. So we have x over tangent of 21.5 equals x plus 132 over 21.5. We can cross multiply and then right, simplify, distribute the right side over here. I'm going to distribute. And then, sorry, I think I distributed and moved over in one step. So distribute, move all the terms with the x over to one side, and then I can factor out the x so that it's easier for me to isolate the x at the very end. Finally, we have, we've solved for x, and our x is approximately 348.86 feet, which is the height of the building.